So chapter 7, we finished chapter 6. What did we learn in chapter 6? What did we do?
Oh, we did distribution, and then we did continuity change factor corrector.
Correct. Continuity correction.
Continuity correction.
And that's because we are going from a binomial, which is a discrete,
Yes.
to a normal distribution. We're making that leap, and in order to make that leap, we had to do that. Okay. What else? We talked about central limit theorem, right? Which tells us that when you take samples from any distribution, any shape of distribution, if you take enough samples, it becomes
A normal
distribution, regardless of what the population is.
Yes.
The sample distribution becomes a normal distribution. Okay, all right. So those are some of the things that we talked about. Now we're going to move on to chapter 7, and in chapter 7 there are 7, 1, 2, 3, and 4 sections. We will not be doing the 4th section. We will be doing 7.1, 2, and 3. And we will actually have a quiz after each separate one. Okay, so we're going to take our sweet time on this. We're going to go nice and slow. Okay. So we're going to do 7.1, we're going to do estimating a population proportion. 7.2 is estimating a population mean. And then on 7.3, we're going to talk about how to estimate the standard deviations of these things. Okay? All right. So why do you think we separate the proportions versus the mean?
One of them is a bias estimator.
Huh?
Isn't one of them a bias estimator?
No, they're both, that's not it. Kind of close, but the whole, remember day 1 we talked about categorical versus quantitative data, right? So if it's categorical data, we get what? We get a proportion or we get a mean? We get a proportion, correct? In a categorical, right? But for quantitative, we're going to get a mean, right? So 2 different things, hence 2 different sections. Okay? So in 7.1, we're going to talk about estimating a population proportion. Population proportion, so 7.1. We have a working one here. Oh, there we go. Estimating population proportion. Okay? So if I have a population, I take a sample. So this is my sample. What do I have here? I have a proportion, correct? Some sort of proportion. Color of hair, or color of eyes, or whatever, right? Certain proportion, right? When I take the sample, what do I get? We get P hat, so this is the population proportion, this is the sample proportion, right? So this is a parameter versus this is a statistic. Parameter, P, statistic. Sample is a statistic. Okay, so you're going to get P hat, and just as Abby said, P hat and P are going to be the same. We talked about this because they are unbiased estimators, right? So we're trying to estimate the proportion. So if I took the sample, why are we taking the sample to begin with? Because we're trying to figure out this guy, right? We don't know what this guy is. We're trying to figure that out. And that's why we take, instead of talking to all 400 students in Blanchett, we're going to do a sample of 20 and say, well, based upon this sample, I think that this, which should be the same as this, is going to be whatever we find. Okay, so that's what we're doing here, right? Okay. So this is a point estimate. Okay, all right. The question is this. So if we do 20, and let's say that I had, I don't know, 5 blue eyes. Okay, so 5 of them were blue. which means that my p hat is equal to what? 0.25, right? So when I say, well, 25% of, so based upon our sample, I think that 25% of the entire population of Blanchett is going to have, 25% is going to have blue eyes. Here's where the rub comes. The rub comes is that, well, how confident are we? How confident about this number are we? Okay? It's like when I do an election poll, right? I did a poll of, I don't know, Gallup poll did a straw poll and said that, well, it looks like Hillary Clinton is leading Trump by, I don't know, whatever, 63%, right? Or 63% of the population or voters are going to vote for Hillary Clinton. Well, do you guys remember when the election, what do they always say? Do they say that, well, it's 63%? What else do they say? Don't they always say that there's a plus or minus something, right? It's always 63% plus or minus 3% error or something like that or whatever. You guys remember seeing this stuff? Right? In the polls, right? It's always this, right? And if you had a poll that looked like this versus a poll that looked like this, which one are you going to believe? The 3%, right? Because this looks a lot better because the range, the possibility here is what? Between 60 to 66, correct? Yeah. Versus if I had this, it would have been, oh, this is pretty large, right? You see that? So which one's more confident here?
The first.
This first one right here is much more confident, correct? Because it has less of a margin of error, right? So this is where we use confidence intervals, okay? So if you flip the page, there is a confidence interval there. The definition of confidence interval. Confidence interval is a range of values used to estimate the true value of a population parameter. So in this case, this is what we're using with some sort of error, right? I don't know what it is, and we'll find out how to calculate this later on. But some sort of error factor, right? This is my confidence interval for estimating this guy. Right? What are some of the things that would make this high or low? What are some things that would control this? Or should I ask the question, would you feel more confident, or would this be lower if you took a larger sample or a smaller sample? So if I took a sample of 2 versus a sample of 20, you would feel more confident with the one with 2?
Yes.
That doesn't make any sense.
No doubt.
How does that make any sense? Can you say, okay, so the population, the entire population, let's say 400 students, and I'm taking a sample here of 20, so there are 2 different choices. Which one would you rather do?
How much is the population?
Huh? Population is 400. Right? You don't. If you did the entire population, you would exactly know, right? And what is that called?
Population.
When you actually go around and ask every single one of the population, there's a word for that. It's a waste of time. It is not a waste of time because the United States does this every 10 years, correct? That's a census, right? There's nothing to guess. What's there to guess when I have the data for everybody, right? There is no sampling. Okay? So it reasons that between these two, this guy would be more accurate, correct? Hence, a smaller margin of error. Okay? And we'll talk about that. Okay, so that's the confidence interval, blah, blah, blah. Then there's a definition underneath that. The confidence level is the probability of 1 minus alpha, such as 0.95 or 95%, that the confidence interval actually does contain the population parameter, assuming that the estimation process is repeated a large number of times. There we go, large number of times, right? A large number of times. Confidence, blah, 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 degree, also called the degree of confidence or the confidence coefficient. Okay, it's usually just the confidence level. Okay, confidence level. Okay, blah, blah, blah. And what is really important here is the interpreting of the confidence interval. So on page 301, it tells you how to interpret a confidence interval. So let's go back to bottom of page 300. It says, here's an example of confidence interval found. The 95% confidence interval estimate of the population proportion P is between 0.405 and 0.455. It is a very common test question or very common thing to ask to interpret this confidence interval. There is a very specific way to do this. So if you go to the top of page 301, the top one is the correct one. We are 95% confident that the interval from 0.405 to 0.455 actually does contain the true value of whatever it is that we're thinking about. All right, so in our case, it would be what? It would be, we are 95% confident that right? Let's say that our interval was plus or minus 3%, so this is our confidence interval. So we are 95% confident that the interval of 0.22 to 0.28 or 22% to 28% contains the true proportion of students with blue eyes at Blanchette Catholic High School. So it's very specific, okay? So if I ask this on a test, I'm looking for word by word here. We are 95% confident that the interval between 0.22 and 0.28 contains the true proportion of whatever it is we're talking about. Okay? Get very familiar with this phrase. Okay, so that's that. 303. And let's quickly look at the little plot there on figure 7-1, page 301. 7-1. So this is what it actually means to be a 95% confidence interval. Can anybody tell me where the 95% comes from just looking at that graph there? If you look at those intervals, all of them are or go through 0.50, correct? All of them except for how many? The one that's in green, correct? So the 95% comes in the fact that you did 20 of these, and one of them does not contain the 0.5, which is the true proportion. So that's what it means by 95%. So if you did 20 samples, all but one of them would contain the true proportion. Okay, right? And that's why when you go back and look at the two wrongs, it says there's a 95% chance that the true value of P will fall between that and that. That is not what it's saying. Right? Again, it's saying that if we did 20 of these samples, all but one of them would contain our true proportion. Okay? Wrong. 95% of the sample proportion will fall between 0.405 and 0.455. 0.455. Again, that's not what we're talking about. Okay, and then we're going to quickly talk about critical values here. critical values. The critical value is, so let's go back to the 95%. So we're going to do 95%. So we've done this before, so it's just kind of a new nomenclature here. Where critical value, sometimes starred, alpha divided by 2. So our alpha, let's say our alpha was, again, 95%. We're doing 95%, right? Our alpha would be what? Alpha would be 1 minus 95, which is 0.05, which means that if I put these two here, this is a z value, right? This is a z-score. And I add these two together, what would I get? I would get 5%. Therefore, this here is going to be 0.025. Does that make sense? Okay. So, how would I find the z value, which gives me 0.025? This is a standardized normal distribution, so you're going to have 0 here. And it's since it's standardized, your sigma is going to be equal to 1, correct? Because this is a definition of the standardized normal distribution. A mean of 0, standard deviation of 1. How would I find this? Must be a Monday. Awfully quiet today. So, let's go look at our table. Look at our table. Go flip back to our table. So let's go to page 6. Page 684. Let's go to page 684. Look at our table. What are we looking for? What are we trying to find here? We're looking for 0.0250, correct? And where are you finding that at? Huh? Negative what? Not negative 2. No, not negative 2.50. No, that's not it. The area has to be 0.025. So in the middle of that graph, you're trying to find where it's 0.025. Were you able to find that?
1.96.
What?
Negative
1.96. So for z-score of negative 1.96. Everybody see that that is the corresponding z-score to that? Are we good there? Everybody see that? Okay. So this is the one. This is a number that you want to keep in mind. So z. We're trying to find the z-score with the corresponding alpha. So when the alpha is 0.05, we just found that the z is this. What if I had an alpha of this? What would my z-score be? What am I looking for now? Instead of 0.025, what am I looking for? Spencer? Huh? No idea? Well, it's 10%, right? So instead of this being 0.025 and 0.025, and now it's going to be what? It's going to be 0.05, correct? So I'm looking for 0.05. I'm looking for in the middle of that graph or that table to find it where it's 0.05. Where is it 0.05?
Negative 1.645.
Negative 1.645. Where does it say that?
There's a little star.
There's a little, do you see on the very bottom where there's that little arrow that goes down there? So negative 6.5. What if it was 0.01? Then on both sides I would have what? I'd have that. Does that make sense? 0.005. So where would I point find 0.005? Oh, it started there again. What is it? Right? Negative 0.275. What's the confidence level here? So the confidence level would be 95% here. This would have been 90%, and this would have been 99%. So these are three numbers that you want to get fairly familiar with. Especially this guy here, right? Because the 5%, remember the 5%? What is the significance of the 5%? This is where I become statistically significant, right? Remember 5%, we agreed to 5%? So the corresponding critical value is 1.96. Okay? All right. Or, what's the other way we can do this? With a calculator, what am I going to use? Inverse norm. I have to do inverse norm, correct? Inverse norm. Inverse norm. Let's do the top one. 0.05 with a mu of 0, standard deviation of 1. What do I get?
Negative 1.644.
This guy right here, right?
Yes.
Right? In order to get this guy, what am I going to change here?
To make the area 0.02.
I have to go 0.025, correct? 0.025. If I do that, what do I get?
Negative 1.95.
Dun, 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 dun. Right? But you see that this is readily available on your calculator.
Yes.
Okay, done for the day. Whoa. I had you guys going through kicking and screaming on this one. All right, we're going to do 9 through 14 for homework.